Hello there. I decided to just go over the answers and the results of our controlled experiment with the Energy Skate Park on a video because some people are done, some people aren't quite done. But I do want you to have your worksheet in front of you as you listen to this. I want you to change your answers if you got some things wrong. I want you to add on to your answers if there's more on my sheet than there is on yours. And then I would like you to tape this into your journal so that you can use it on the quiz when we have it. Okay, so that's your job after you get done listening to this and filling in the information that you might have missing. Okay, so we did this together in class as far as we determined that what we were testing is the mass. And once again, that can be found in the problem question. How does mass affect or change speed and kinetic energy? The dependent variables were speed because we were going to, collect information about that, and kinetic energy, which is moving energy, and we were going to collect information about that. Okay, so you should have that done. The hypothesis, this is what you predict before you even test anything out. I guess my prediction is that if we make the mass bigger or increase it, then the speed's going to increase and the kinetic energy will increase. And then, kind of vice versa, if we decrease the mass or make the skater smaller, then the speed is going to decrease and the kinetic energy will decrease. So that was just my prediction before we did the test. So once you went to the testing site and you manipulated the mass and you moved the skateboarder up to the top and you stopped it at the bottom, excuse me, then you were recording where the speed dial or the speedometer stopped and how far up the kinetic energy went on this arrow. I remember we were kind of making a little halfway point on ours so that we could use that as a reference point. So with the default, with the mass in the middle, I got that the speed was just a little over the line from like straight up and down. And the kinetic energy bar was slightly below halfway up the arrow. And then when I changed the mass to be all the way over, then the speed was basically in the same spot, but the kinetic energy went pretty far over the halfway point. So that's what I drew on my data table. And then when we changed the mass clear down to make the skater small, the speed once again basically stayed in the same spot. That was surprising to me, but the kinetic energy was way below where the midpoint was. So this is the data that I collected for that. So basically the speed stayed the same and the kinetic energy increased with the mass or decreased with the mass. So if you didn't have those results, you might kind of change your data table. Then on the back, this is where people kind of got a little bit confused. The controlled variables, what was it that stayed the same? Well, a lot of people wanted to write speed because the speed didn't change. But the speed, remember, is one of the dependent variables. So if you wrote it down, it's not really wrong, but it's not a controlled variable. The ramp shape was controlled. That stayed the same each time, or it should have. You shouldn't have been messing around with that. The skateboarder, basically the skateboard stayed the same, and the starting height stayed the same. If you put the grid on for any reason, you could see that it kind of, we were testing it at a 6-meter height, starting height, then hopefully you moved the skateboarder up to the very top each time. So that was a controlled variable. There's probably some others. So if you had other ones, that's awesome. If you didn't have these, you might write those down. Which test do you think was the control? Well, basically in this situation, we were comparing the increased mass and the smaller mass to the default or the middle. So in this situation, the control was the default mass. What were the results? Well, sometimes, instead of just writing down numbers and having people figure it out, you have to write it down in the words. So it was simply the mass did not affect the speed. The bigger the mass, the more the kinetic energy. The smaller the mass, the less kinetic energy. So you might want to stop and write that in if you had something that was different. If your words mean the same as my words, then you don't have to cross out what you've written, but I just want the results in a written form as well as data as a picture. All right, we're almost there, people. The conclusion. Here's what really happened. If we increase the mass, then the speed will stay the same and the kinetic energy will increase. That's what actually happened, okay? And if we decrease the mass, the speed will stay the same and the kinetic energy will decrease. So this is what everybody should have alike. Even though we might have made a prediction that was different, the results should have all been the same. So change that if you do not have that information. And think about it, in real life, if people were like down at the skate park, all right, what other factors could have affected how the skateboarder would go? Well, the height of the skateboarder might have been a factor. The weather, if there's wind or rain or heat, that's going to affect the rain and the heat could certainly affect how the wheels on the skateboard roll down. So I just like people to think about all the different factors that could change the results. And then if we did an experiment again, maybe we could change the starting height. Maybe we could go back and actually move the starting height. I don't know if it'll let us do that. Anyway, we could have gone to 8. Maybe we could have changed the shape of the ramp and tested that. That might have been cool. Maybe we could test whether there was friction or not. Maybe we could test the type of skateboard with a different program, or if you were in real life, you could do that. So there's a whole bunch of different things that you could test. But remember, for it to be a controlled experiment, you can only test one thing at a time and then control everything else. So, like I said, why don't you make sure that you've got the sheet filled out, you've got the correct answers, you've got the correct data, and then go ahead and tape this in your journal, and you can use it on the test that we're going to have sometime in the very near future.